In this video, I just want to talk about some of the basic properties of logs and exponentials. We'll begin with exponentials and just remind ourselves that if we have e to the a multiplied by e to the b, that is the same as e to the a plus b. And if we have e to the a raised to the b, that looks like e to the a times b. Now let's turn to some useful properties of natural logs. One of the most important useful properties is that if we take the natural log of a product, we can turn that into the sum of individual natural logs. And the same works if we're dividing, that turns into the difference of natural logs. To prove this, at least for the sum case, we can simply take this expression and raise e to that power, right? So if we take e raised to the ln of a plus b, we know that we can simplify that using this identity here to the natural log of a, e to the natural log of a multiplied by e to the natural log of b. But this term is just a, because e to the natural log of some variable equals that variable. So this term is just a, and this term is just b, so that must equal a times b. But I also know that I can rewrite a times b as e to the natural log of a times b, because I can write a variable, a times b, as e to the natural log of that variable. So then we end up with this must equal this, and we could take the natural log of both sides of this to get back to our original equation here. Okay. So that shows us that if we have the log of a product, it can be written as the sum of the logs. And the same exact thing happens here, except you pick up a minus sign here and a minus sign in your exponent. Another nice property of logs is that they turn exponentials into multiplication. The way to see this is if we think about adding up the log of a n times, well, that looks like n times the log of a. But if we use this property of natural logs here, where we say that the sum of two natural logs looks like the log of their product, well, we can then take and write this as the log of the product of all of these a's. And the product of a multiplied by itself n times is a raised to the n. So we have that n log a equals log of a raised to the n. And we will almost always run this way. So we will see something which it looks like the log of an exponent, and then we will turn that into the exponent multiplied by the log of the variable. Okay. Other useful properties here, if we take the natural log, this is our previous statement, but I've added one more step here. So we're using our exponent function here, our exponent knowledge here, to say that the natural log of e to the a looks like a multiplied by the natural log of e. But the natural log of e, I pull down the thing that is the power of e, right? Taking the natural log undoes e to the power, and the power here is 1. The natural log of e, which I've written over here in one of my handy equations to know, the natural log of e is just 1, right? Because the power that e is raised to is 1. Okay, so the other one, this we already know, and then we have b times the natural log, e raised to the b multiplied by the natural log of a. We can use our property here. We have e to the, in this case, natural log of a raised to the b. So we can take this and write this as e to the natural log of a is just a, and that is raised to the b using this property here. Okay, the last thing that we should do is just talk about some of the limiting cases of this. E to the 0 is 1, because anything raised to the 0 is 1. e to the negative infinity looks like 1 over e raised to the infinity, which is definitely 0. And the log of 0 is negative infinity. So this is asking the question, what do I need to raise e to in order to get 0? Well, if I want to get 0, I have to raise e to an enormous negative power, right? I need to divide 1 by e to some enormous power. How big? Well, infinity. So the log of 0 is negative infinity. Just another few things that it will be handy to know. Here we have the e to the b multiplied by the natural log of a. We can use this property that we already discussed about multiple exponents in an e raised to the something to write this as e to the natural log of a raised to the b, but this term in parentheses is just a, so we have that as a to the b.